So our first speaker today is Ryan Ball, who will be presenting bringing your internal tools to the next level using Alectrona Patch. So without further ado, here's Ryan.
Hi, everyone. Again, I'm Ryan Ball. I'm a Mac consultant engineer at Alectrona. And what we're going to talk about today is a tool that began as an internal tool for us called Alectrona Patch and how we brought this to the next level. So in early 2021, we released Alectrona Patch, which is a SaaS offering to help Mac admins keep software up to date with little to no manual work. But we didn't set out to make a product initially. So how did we get here? Well, initially, we simply wanted to solve our own problem. And that problem for us, again, was patch management. So let's talk about our patch management situation. So we have multiple customer MDMs that we have to make a solution work for. So it has to be, kind of scalable so that we can accommodate this in several different MDMs. We had customer compliance policies that indicated that, specific applications needed to be up to date. And we were doing that through various methods. Some of those methods were like static packages, and I call them static packages because the software version is static within that package, and it might be good for a few weeks, it might be good for a few days, and then it's completely out of date. And we also leveraged a handful of custom scripts to do some of this patching as well. So we really were doing it a few different ways. And for us, open source tools didn't quite fit our need. So again, we had to look elsewhere for a different solution. And we ultimately had limited bandwidth to do it right. So the solution that we needed had to work for us and our team, without taking up too much time. So let's identify some of our requirements that we had. So what we wanted was something that was cloud native that didn't require us storing any packages. And the way we were going to do this was we were going to install software obtained directly from the vendor. We wanted the tool to be configurable via a configuration profile. We wanted it to be scalable and extendable because again, we have multiple MDMs that we have to manage and a variety of different applications that need to be installed and updated. So it had to be extendable as well. It definitely had to be a secure solution. We didn't want, to do something that was insecure and cause any sort of security compliance issues for any of our customers or ourselves. We wanted something that resulted in a great end user experience. So we didn't want something that was going to require logging out before an application got updated or anything that really, made for a bad end user experience. And of course, we wanted to make it easy on ourselves, and that way we can implement patching solutions easily. And again, extend the functionality to make sure that we were able to patch everything we needed to. So when you're dealing with software packaging or software patching, there are specific data points that you kind of need in order to do that, right? So what are some of them? You definitely need a download URL. Where are you going to obtain the install media from? The latest version is obviously helpful. The checksum of the install media that we need to download, right? So making sure that the install media that we've downloaded is actually what we expect it to be. So in an applications info.plist file, we need a key that we can use for version comparisons to ensure that we either need to install the application or update the application. Because we want the software to be secure, we needed to have signature information for the application itself. That way, when we attempt to install the app or the package, we can verify that, again, it is what we expect. And then another required data point would be the install method that we use to get that application installed. So is it going to be a package? Because again, we're pulling this software directly from the vendor. So it could be a DMG with an app inside, could be a zip file with an app inside. There are a lot of different methods that vendors use to package software. So we needed to kind of identify all those different install methods. And so once we knew kind of some of those data points that we needed to install or update software, what did we need to build? So first, what we wanted to do was create a command line tool to do most of the installs and updates client side. We wanted an application that we could use to supply end user notifications when applications were running, and we needed to show the user that an update was required. We wanted a daemon to automate the command line tool so that we could actually schedule the command line tool to perform updates, potentially without MDM policies. We had to create a REST API as well to get the patch catalog data. So we're going to run the tool, the command line tool client side, and obtain data from a catalog to determine those data points that we mentioned were required earlier. And then in this patch catalog, where we're storing all this data related to software titles and versions and URLs and things like that, we wanted some of that to be automatically populated. So first, we start with the patch command line tool. And initially, what we did was we used bash. So yes, Alectrona patch began as a bash script, and Arnold approves. So what bash allowed us to do was develop a working concept, a working proof of concept using a language that we were pretty familiar with. Again, those data points that I indicated were required initially, having a proof of concept really let us validate those data points. And so we can take those data points to safely patch a variety of software. So again, with bash, we were able to figure out kind of the entire workflow of the process. And so we could then understand where things could go wrong in the process. We were actually able to leverage the bash script that we created in MDM policies so that we could test the workflow extensively. And then again, since we did write it in bash, there was some room for improvement. So what did we need to do to create a truly great command line tool? Well, we got Swifty. So patch was completely rewritten in Swift. What Swift did is provided improved performance over bash, significant in fact. Swift is designed for safety, and again, we wanted something that was safe and secure, and the Swift and its frameworks allowed for that. And Swift provided a modern foundation that will allow us to support Alectrona patch for years to come. So let's take a look at the patch command line tool in action. This is a quick sneak peek. If you want more, you have to book a demo with us. But so here what we're doing is we're running sudo patch install command, and we're installing FileZilla. We're adding in a progress flag. And what we're doing kind of in the background is we're again, we're reaching out to the patch catalog, determining what the latest version is of FileZilla. We're doing a comparison on the fly with FileZilla that's installed. We download FileZilla. We make sure FileZilla is not running. In this case, it wasn't, and then we install FileZilla. So one simple command to get the software installed. So the next piece we talked about building was something to notify the end user when an application was running and required an update. And what we built, we call it Patch Notifier. And again, it's written in Swift. And this next point is kind of the reason why we went down the path in creating this tool, is because it minimizes dependencies. So we didn't need to leverage something that the MDM bundles into their product because we didn't necessarily want to be tied in to using something that may not be available for everybody, or using something like AppleScript to do a dialog. We wanted something that we could create, we can control, and again, just minimizes dependencies. And we wanted something that was simple and familiar. We didn't, want it to look really out of place. And we wanted it to be something that people probably recognized. And this is what it looks like. So what you see here, this is an example of the application prompting the user that Zoom needs to be updated, and Zoom is open. You have an option to click update or later, and finish the rest of the process with the command line tool. And in fact, the patch notifier itself is a command line tool as well. So here we're just running the command line tool, or there's an application with a binary inside, and we're running the help to get pieces of the command line tool that you can configure. One is friendly name. So the friendly name of the application that we're attempting to update. So in this case, we'll just set the friendly name to Google Chrome. And you can see an example of the dialog. Again, one of the options is to pass in a URL of the ICNS file, which is why you saw the Zoom icon. So when someone clicks update, you can see it exits 0. Here, we're just showing if you click the later button, you can see that it exits 1. So we're kind of exiting different ways depending on what button you press. And then again, another option is a timeout. In this case, we're going to choose to time out in 5 seconds. So no buttons are being clicked. This is just timing out and exiting. And as you can see, we're exiting differently than we did even after clicking both the buttons. And now we're just getting fancy. We can change the label for the defer button. In this case, we're being real passive aggressive, and we're just changing that label button to say nope. So you have the option to update or nope. So again, it's it's cool because we're able to control the dialogue exactly how we want it, and we're not depending on any other third-party software to do these dialogues. So the next portion, we wanted something to automate the command line tool. In this case, we chose a daemon. I always call it daemon. I need something really to remind me that it's daemon, so I have that. But we actually call it the patch agent, even though it is a daemon. And again, you're probably seeing a trend here. The daemon is written in Swift as well. So the daemon can actually be configured with a configuration profile. So the reason why we kind of have that is, if we have a list of applications that we want to patch, we can set them up in a configuration profile, and we deploy the configuration profile to a device that has Alectrona patch installed. And it basically can keep itself up to date without, again, any MDM policies to do that. And again, it allows us to update software without an abundance of MDM policies or groups, which is awesome. So again, it automates the patch command line tool, so it kind of controls that, and it listens for update notifications that get posted from the patch command line tool. So the daemon is actually made aware of when installs or updates happen. And the daemon runs on a schedule. So here's an overview of kind of the functionality of the daemon itself. So again, you have the patch agent in the center and the patch command line tool already installed on a device. You install a configuration profile that has kind of that list of applications we want to install on the device. The patch agent then reads the configuration profile, gets that data back, and then essentially creates kind of a job list of things to do, right? So in this case, the job list indicates that we want to update Slack, we want to update Firefox, and update Zoom. So then the patch agent goes, okay, now I know what to do. So let me tell the patch command line tool, hey, try to install or update Slack. And then the patch command line tool determines if Slack needs to be updated or installed, and if so, does the installation. And then again, because the patch agent is actually listening to notifications from the patch command line tool, the patch command line tool then says, hey, I did the update for Slack. And then, we kind of check that off the list, and then we move on, right? So we go, the next phase would be to attempt to update Firefox and then attempt to update Zoom. And again, the patch agent runs every 4 hours by default. So several times a day, again, without any policies, in any MDM policies, the patch agent will attempt to update or install the software every 4 hours, which could be, 2 or 3 times a day. So let's recap our build list. What did we say that we wanted to build initially? The first thing was the command line tool to do most of the work client side. The second was the application for the end user notifications. We wanted the daemon to automate the command line tool. The next piece is the REST API to get that patch catalog data, right? So the patch command line tool needs to get all this information about these applications in order to intelligently determine if it needs to update or install the piece of software. So let's talk about the patch catalog API. So again, it's a REST API and it's built in AWS. What it does is it returns data required to install or update a specified app. So the patch CLI tool looks to the patch catalog and says, hey, I need information related to Firefox. And then the API returns that data about Firefox to the client. It also provides mechanisms for reporting. So one metric that we might report on is how many devices that are leveraging a single license key are attempting to use the patch software, so that we can kind of, see if we have too many devices using a specific license. And much of the patch catalog is curated automatically. So one thing that we really didn't want to do is, manually update all these fields in a database when software, new versions of software came out. So we had to find a way to automatically populate a lot of that data. And all the traffic from client to the API is encrypted with HTTPS, as you would expect nowadays. So let's do an overview of the API itself and how that kind of functions. So you have a client on the left with Alectrona patch installed. Again, the Alectrona patch tool will, again, we'll use Firefox as in this scenario. We need to install Firefox. So it reaches out to our API gateway and says, hey, I need information related to Firefox. And the API gateway on the back end essentially runs a Lambda function in AWS, which then the Lambda function says, hey, give me all the information related to Firefox. That data is returned to the Lambda function, which is then returned to the API gateway. And then the API gateway then returns that data in a JSON format to the client. And at that point, the patch command line tool could then process the data that we got and then does its thing and determines if software needs to be updated or not. And meanwhile, the metrics for reporting we were talking about gets sent to CloudWatch. So that's a kind of an overview of the entire API process. So let's show you how we can take some of that data from with using the patch command line tool and print it to screen. So here we're doing a pseudo patch list. And essentially what this will do is just list a small summary of each software title in the catalog. And as you can see, I'm kind of scrolling up. There's just a few fields that we're including in this list. It's really just to kind of give you a summary. And because that data is in JSON format, we love JQ. So we're just kind of showing you how you can leverage JQ to pull a specific field from that JSON, in this case, the app file name. So that same entire list, we basically just parsed and grabbed just the app file name, which is kind of neat. Again, we can take a listing or get a list of a specific application as well. In this case, we're choosing Dialpad, and that data gets returned to us in JSON format. And if property lists are more your bag, you can actually get that data converted to a property list on the fly as well. So that just kind of shows you a portion of the data that's in the patch catalog related to software, and how we can list that and kind of manipulate that. So we talked about the patch catalog being automatically populated. And so we're doing that through a CI/CD mechanism. So we're using Circle CI. What we do is we run a series of automated processes using Circle CI. And these processes are scheduled via cron in the Circle CI job. And it's ran in a macOS environment, which is really the key aspect of this, because what we're doing is we're installing application and doing testing on those applications, right? By looking at application signatures and versions and things like that. And if this was run in just a pure Linux environment, obviously the software install wouldn't occur. So us, doing this, or having the ability to do it in a macOS environment is awesome. There are a few other CI/CD shops that would allow you to use a macOS environment. Circle CI has worked great for us. So again, that's the key aspect in this is that it runs in a macOS environment. We use it to detect changes of install media URLs. So obviously, we want to make sure that we have the most current URL. And it can discover new software versions. So again, if we're installing some of these applications to do testing on and the version is updated, we can discover that and then we can update the patch catalog automatically. This also allows us to identify areas for human intervention. So there are times when specific applications, if there's an update to it, maybe the application name actually changes, which is odd, but it does happen. And just some other areas where we might need to take some action. So a lot of these things are, we can kind of pinpoint where we would want to receive notifications, and any changes that do occur, we're notified of that. So any time that there's an update to an application, we're made aware. So we're always in the loop. So again, let's recap some of the things that we needed to build. We went over the REST API to get patch catalog data. and automated patch catalog population, right? So using Circle CI to run some of those automated processes to get new versions and test software installation. So what are the lessons learned? What did we learn? First off, patch management is hard. That's just the way it is. This was a really fun, process for us. We learned, specifically a lot about, things related to patch management, what the best methodology is in terms of notifications and, what, makes people feel uncomfortable that they, seeing on their screen and things like that. So again, kind of this whole process has been hard for us, but I think that, the result has been great. One solution may not be right for everyone, and this is not necessarily specific to patch management, but some tools that you use, even though they're internal to you, they could be right for somebody else. So keep that in mind. We obtain feedback throughout the process from end users and from prospective customers as well. And so you should welcome feedback and take it seriously. Don't just drop it into some queue and it might get looked at in the future. You should really take it seriously because it brings a lot of value to you and your company and your product. And that's it again. I hope you enjoyed it. I'm Ryan Ball at Alectrona, and be happy to answer any questions you have. Thanks a lot.
Thank you, Ryan. Fantastic. So Josh and I have a couple questions for you. I'm going to go ahead first here. We have from Anonymous, will Alectrona maintain a universal patch catalog, or will each individual instance have to develop its own catalog?
So we have, it's an internal patch catalog. So it's universal.
Okay. Our next question comes from John, and he asks, does Alectrona patch support custom packages? For an example, if we wanted to include certificates or specific configurations with the updates.
So again, all the software that you could obtain with Alectrona Patch is publicly available software. So custom packages, if it's a package itself, may not be something we support, and that's, we kind of designed it that way to obtain the install media directly from the vendor. But we do have pre-install a flag and post-install flags that you can use at the command line to do something ahead of time or do something after the fact. And only in the event of an update will those pre and post-install commands get run. So, there are some ways where you can kind of, if the idea was to run some sort of command afterwards, if that's what you're doing in the post-install, like that could be done just at the command line. And if you're leveraging an MDM where, you have kind of a hierarchy of things that could be done, you could have a post-install script that does some of that customization as well. So.
Excellent. Is there a countdown, timer, or snooze feature and fire off on a date?
So there is a postponement option, right? So if you click the later button, then kind of the process halts. And again, since if you use it in the automated mode with the daemon, which is optional, you can, again, the process would run again in 4 hours. So they would have an option to do that update if the application is running in 4 hours. We have received some feedback about if for some reason somebody postpones like X number of times, maybe you do something, which some people might take advantage of the fact that, hey, this person's postponed 4 times. Let's just kill the application, which is not necessarily ideal, but that's something that we have gotten some feedback about that, and we may implement something like that as well. We also have an unattended flag that we can pass in that basically treats it as if the Mac is unattended. If the application is closed, there's no dialogue. It just, or if the application is running, pardon me, it will just close the application, do the update, and then launch the application again, which is, it was mostly intended for conference rooms where maybe something like Zoom, the Zoom rooms is open all the time, and maybe after hours you could use the unattended flag, but there are things, and we're looking at some others as well.
Great. So our next question, it comes from Patrick, and it asks, does this work for the Adobe Creative Cloud suite of applications?
So Darren probably could tell you most likely, well, I mean, so we do have Adobe Creative Cloud Desktop, right, that you could patch with it. And then also Acrobat and Acrobat Reader. So those are the components that are really easily publicly available that you can patch. Some of the other pieces of software, you know, like Photoshop and things like that, are much more difficult. You may, you know, there are some licensing aspects as well. Do you have to get the package from the Adobe console, or could you just use a straight package that you could create and then somebody signs into it? So there are a lot of variables. But to answer the question, you know, the Adobe Creative Cloud desktop app would be available. Acrobat DC and Acrobat Pro, those are the pieces at this time that are available.
Okay, can Alectrona patch be used for installs?
Yes.
Take it out of the box OS.
Yep. So what we do a lot of times is, you know, if we have, we're setting up an enrollment workflow using something like DP Notify, you can leverage patch in just policies to install things that didn't pre-exist. You could also leverage it in self-service type workflows as well, where again, you know, the application doesn't exist, someone wants it installed, they can do that. Great.
Can this be used for unsigned packages? Would that be an option?
So as an example, docutil, which is a command line tool that you can use to modify the doc on a Mac, that's a package that's not signed, right? So in our patch catalog, for the signature of the app, the package itself is blank. So technically, we can still install an unsigned package. The trouble is, if for some reason the vendor then later signs the package, we're kind of doing a comparison and we're not expecting it to be signed, so we'd have to manually kind of ensure that that's up to date. But I think most, 99% of the things that we're installing is all signed, either packages or applications. So the answer is yes, it can install unsigned packages, but it depends on the use case, really.
Okay, is there a public list of supported titles?
We do have a website it's publicly available, but the URL is just really not known. That we have everything in it's basically the site that we use to create a configuration profile for patch. So yeah, I can determine if we can post that, and then we could probably give that out, because that would give a listing of all of the things that were in patch.
So I'd say if anyone's interested in that, follow up in the Slack channel at a later date.
Yeah, for sure.
This may have been asked before, but go ahead and just go through it again. But comes from Anonymous, might have missed it, but is there a way to defer patches for a period of time, say for vetting or testing?
So yes, the way you probably do that is for specific software that you want to patch in that way, some sort of testing workflow, a small rollout. You may not include that particular software in the configuration profile to automatically be patched. Or you could take that configuration profile and scope it to a small subset of your devices to get the latest version. And then once you've deemed that it's okay, then you could then modify the configuration profile that might be scoped to the rest of your fleet. to then include that. If you didn't leverage the automated mode of the daemon, you could do a like a Jamf Pro policy to do the installation for a subset of Macs as well. And there is another kind of option that we're looking at in kind of capping at a specific version for folks. So if for some reason they know, version 12 is what they want their devices to be at, if version 12 is not available anymore, then obviously that it wouldn't work. But there may be a way that we can cap it at specific version as well. But the idea would be you just configure your either policies or configuration profiles to patch specific devices ahead of time, and then adjust it once you know that that's software is okay to use in your environment.
Excellent. So we are just about out of time, so I think this is our last question. And it's a big one, so forgive me, I'm going to have to read this out, and just let me know if I missed any parts. How does the Alectrona patch client on the local Mac OS device determine what products need to get patched? Does it scan the device for available software that's within your patch catalog? Or does a specific config need to be provided to tell the Alectrona client which products to patch? Is there a way to skip updates for a specific product or defer them if there is a reported issue? And I think you might have just touched on that.
Mm-hmm. Yeah, so that's a few questions. So the first one, how you would basically you create the configuration profile. So you say which specific applications you want to be patched. So you're in control of those updates as far as which software we're looking at to patch. In terms of deferment, yeah, we kind of talked about that. You can, if for some reason the device is configured to patch Slack, for instance, the user could potentially postpone that using the dialog if it's running, and they don't want to close Slack out. Or again, you could set up the configuration profile in a way that you would only scope it to devices where you wanted patch to be, or where you wanted Slack to be patched. So yeah, that would be the. Hopefully that answers your question.
Okay, perfect. Well, thank you very much, Ryan Ball, for taking the time to deliver today's first session.